The potential of augmented reality, AR, in space missions represents a paradigm shift in how astronauts interact with their environment, conduct research, and carry out complex tasks. Our technology overlays digital information onto the physical world, enhancing the user's perception of reality. This capability is particularly valuable in the extreme and information-rich environment of space, where efficiency, precision, and situational awareness are paramount. In the context of space missions, AR can be used for a variety of applications, from aiding in spacecraft maintenance to enhancing scientific research and even improving life support systems. One of the most immediate applications of AR is in the maintenance and repair of spacecraft systems. Spacecraft are complex machines with intricate systems that require regular maintenance. AR can provide astronauts with real-time, step-by-step visual guidance for repairs, overlaying digital instructions and diagrams directly onto the components being serviced. This can significantly reduce the time and potential for errors in conducting repairs, a critical factor in the time-sensitive environment of space missions. Furthermore, AR can play a crucial role in assembly and construction tasks in space. As we venture towards establishing bases on the Moon, Mars, and beyond, astronauts will need to assemble habitats, solar arrays, and other infrastructure. AR can assist by visualizing the final assembly, guiding the placement of components, and ensuring structures are built accurately, efficiently, and safely. Another promising application of AR is in scientific research and exploration. Astronauts on planetary missions can use AR to overlay geological information, historical data, and scientific annotations onto the landscape they are exploring. This can enhance their understanding of the geological features, guide sampling operations, and provide immediate contextual information about their surroundings. AR can also facilitate remote collaboration with scientists on Earth, allowing them to guide astronauts in real time during exploration and research activities. Navigation and situational awareness are further enhanced by AR technology. In the disorienting environment of space, especially during extravehicular activities, EVAs, or on the surface of other celestial bodies, AR can provide astronauts with heads-up displays that show navigation waypoints, highlight objectives, and warn of potential hazards. This can improve the safety and efficiency of EVAs, a critical aspect of mission success. AR also has the potential to revolutionize training and simulation for space missions. Astronauts undergo extensive training on Earth to prepare for their missions, with the ability to simulate and interact with a realistic representation of their working environment can significantly enhance this training. AR can create immersive simulations of spacecraft, the International Space Station, ISS, or planetary surfaces, allowing astronauts to practice tasks, familiarize themselves with their environment, and rehearse procedures until they become second nature. In terms of life support and habitat management, AR can assist astronauts in monitoring and controlling the myriad of systems that keep them alive in space. From air quality and water recycling systems to power and thermal management, AR interfaces can provide intuitive control and monitoring, ensuring that astronauts can quickly respond to any issues that arise. Moreover, AR can contribute to the psychological well-being of astronauts on long-duration missions. Isolation and confinement are significant challenges for crew members on missions to Mars or other distant destinations. AR can provide immersive experiences that simulate environments from Earth, offering a mental escape and helping to alleviate feelings of isolation. The integration of AR in space missions, however, is not without its challenges. Developing AR systems that are robust enough to function in the harsh environment of space, user-friendly for astronauts with varying levels of technical expertise, and capable of operating with the limited computing resources available on spacecraft is a significant engineering challenge. Additionally, ensuring that our devices can function in microgravity, withstand radiation, and not interfere with spacecraft systems requires innovative solutions and rigorous testing. In conclusion, the potential of augmented reality in space missions is vast, offering tools that enhance the efficiency, safety, and effectiveness of astronaut tasks ranging from maintenance and construction to scientific research and exploration. As our technology continues to evolve, its integration into space missions will likely become increasingly sophisticated, further expanding the possibilities for human exploration and habitation of space. The ongoing development and deployment of AR in space missions represent a significant step forward in our ability to explore and operate in the final frontier, marking a new era in human spaceflight where digital information and the physical world converge to enhance our capabilities beyond Earth.